Hi everyone, my name is Patrick Jackson, and I'm an engineer with Willow Tree. Thanks for sticking around for the last session of the conference. I'll be talking about reduxkotlin.org. It's an implementation of Redux in pure Kotlin that supports multi-platform. Now, you may be thinking, do we need another Redux library? And I think the answer is yes, and it needs to support all of Kotlin's platforms. So what is this talk? The purpose of this talk is to present reduxkotlin.org as a standard implementation of Redux in Kotlin and to propose a central place for all things Redux in Kotlin. I'll talk about this collection of libraries, how they can be used in native mobile development, and I'll also talk about why Redux is a good architecture for multi-platform development today and into the future where we have SwiftUI and Jetpack Compose. So this talk is not an intro to Redux. I'll do a quick overview of Redux, but if you are new, I would recommend watching a great talk from yesterday titled Redux for Android by Elliot Ginger. And also there's another talk from last year from a coworker of mine from Willow Tree named Redux on Android, the Nitty-Gritty by Nish Tahir. There's another talk today from the Netflix folks about using Redux. And that makes 3 talks about Redux at this year's droidCon. So I'd say this is a growing architecture. During this presentation, I'll talk about how to use Redux to share code between Android and iOS. And I'll discuss how using Redux will set up your project so it's ready for Jetpack Compose and SwiftUI. Can I get a show of hands? Who has used Redux in native mobile development? All right, we got one. Is anybody familiar with Redux? Okay, cool, got a few hands. First, a quick recap of how we got here. Redux was created in 2015 by Facebook engineers Dan Abramov and Andrew Clark as a solution for state management in web applications. It's known for predictable state management and using a centralized state. In other words, your application state is in one global object. Redux is often thought of as related to React, but they are completely separate libraries that do work well together. Redux follows 3 principles: single source of truth, state is read-only, and changes to state are made with pure functions. By following these principles, state for the application becomes predictable, and possibility of bugs due to stale state or state being duplicated in multiple places within the app are just gone. Redux consists of a store object that contains functions for dispatching actions, subscribing to state changes, and getting the state. The global state is contained within the store and can be changed, only be changed by an action sent through the dispatch function. Actions are objects that contain any data necessary for the new state or for side effects. Actions basically represent any change to the system. They can be UI events or success and failure from network calls, for example. Middlewares are functions that have side effects and do not change the state. Logging, networking, analytics, and routing are examples. The reducer is a pure function that creates a new state from the old state and the action. Listeners that subscribe get notified when a new state is created. This pattern creates a clean, unidirectional data flow. And this is all of Redux. It really is a basic pattern and a very small library. It's only 8 files for Kotlin Redux. If you're new to Redux, this may sound complex. However, it's quite simple. It really is actions are dispatched. Middleware can take action on those and a new state is created and subscribers are notified. The simplicity and design of Redux allowed for an ecosystem of middleware, store enhancers, and dev tools to emerge. All of these links are libraries and that add capabilities or improve developer experience for the web. They're all built by the community. There are hundreds solving things from asynchronous actions in a unit testable way, persistence, logging, hot reload of state, action replay, state visualization, integration with other frameworks, handling of forms, and many more. It's really amazing how many are out there. None of this would be possible if it was not a standard implementation of Redux. For a statically typed language, such as Kotlin, it's even more critical that a standard library exists to enable sharing of code. Now, many of these libraries are specific to JavaScript and the web and would not make sense for native Android or iOS development, but they can be a source of inspiration. There are some really interesting approaches to complex async actions in a way that's easy to read and write tests for. One example is called Sagas. It uses JavaScript generators to handle complex series of async actions in a way that's easy to read and write tests for. With Kotlin and suspend functions, we could implement this in a similar fashion with generators. I'm sure there's many other libraries that can be made specifically for Android and iOS. So Redux quickly rose to become one of the most popular state management libraries for front-end web development. It wasn't long before the mobile world started borrowing the Redux pattern for use in native applications. In early 2016, we began seeing talks and blog posts on Redux for Android and Redux for iOS. Since then, many Redux libraries have been written for Android and iOS. These are just some of the libraries on GitHub. Redux on Android also has been used by major companies, such as Netflix. Okay, so Redux is a simple library, easy to implement. However, despite all these libraries, Redux has not soared in usage as it has for the web. I believe there are three main reasons for its popularity on the web. One, it had a standard implementation, and this allowed an ecosystem to grow. Two, it solved a particular problem with React. React's declarative UI code works particularly well with a Redux global state management. Given that Google and Apple both announced new declarative UI frameworks this year, this is really interesting. They will likely be a good use case for Redux with Jetpack Compose and SwiftUI. I'll talk more on this later. And another reason, the dev experience with Redux in the web is pretty great. It's got hot reload, time travel to speed feedback cycles. I don't think we'll ever have anything like hot reload on Android or iOS, but I think there's room for improvement. So bringing it back to reduxkotlin.org. Redux Kotlin was written with the hopes of becoming a standard library for Redux. Redux Kotlin is written in pure Kotlin and supports all the platforms that Kotlin has. I created it during innovation time at my employer, WillowTree, while exploring multi-platform architectures. The implementation is basically a port of the JavaScript version, keeping the same structure and names. With Kotlin, we can write code in a more functional way than Java, and this makes the code much more concise. The goal of the project is to provide standard Redux library to the community. The reduxkotlin.org domain name and GitHub org have been created, so it's not owned by an individual or a company. And the hope is to grow this as a place to go for resources. On the main repo, I've outlined core values to guide decision-making for the project. One, the core Redux library needs to be a minimum implementation, and other libraries build upon that. Two, modular development, following the example of JavaScript. Three, support all of Kotlin's platforms. Four, develop in the open and enable communication via open channels, such as Slack and GitHub. And five, not owned by an individual or a company. So I think by closely following JavaScript Redux example, that'll make porting other middleware and dev tools easier. In addition, sharing ideas and possibly code with web teams will be easier. And there's no reason why you couldn't share code between iOS, Android, and the web using Redux for state management. I've written this initial implementation of Redux, Thunk, Reselect, and a few other middleware and sample apps. And I see this as a starting point and welcome any feedback and contributions. If you're using Redux in Kotlin, please take a look. You also find channels to communicate and collaborate on the repo. All right, to be clear, Redux Kotlin is written entirely in Kotlin and supports all the platforms that Kotlin supports. If you're new to multi-platform Kotlin, that includes the JVM native, which is iOS, macOS, Windows, Linux, JavaScript, and WebAssembly. The shared Kotlin code is compiled to native executables for each platform. For JVM, this is bytecode, and for native, it's a native binary without a VM. With all the Kotlin multi-platform material here at the conference, you probably already know all this. It's still early days, and it's experimental status for the Kotlin multi-platform, but a lot of the fundamentals are in place. There's a solid Gradle plugin by JetBrains. There's networking support with Ktor, serialization with Kotlin X serialization, SQLite support with SQL Delight, and local storage with multi-platform settings. Even debugging Kotlin with Xcode works through the use of an Xcode plugin created by TouchLabs. So being able to share code between these platforms and write it in a language like Kotlin can be really powerful. The value proposition of creating a standard Redux library is now much greater. With Redux Kotlin, you can write much of your code in shared Kotlin, then write a very thin view layer in the platform's language, such as Swift or JavaScript. All right, so how can we architect a multi-platform app using Redux? This diagram shows the most basic way. Everything on the left of the dotted line is written in shared Kotlin. This includes the store with its reducers, middleware, actions, and the app state. This includes networking, local storage, and database code. So this is the heart of your app, the logic for deciding what to display, state management, and fetching and storing data. This also means you can test all this code in the shared module, which is another reduction of work. On the right side is the platform-specific code. You write activities, fragments, view controllers on iOS that they dispatch actions directly to the store and subscribe to state changes. These then render the view based on the state object when a change occurs. This creates a unidirectional data flow, which is widely regarded as beneficial. Having UDF makes the view a function of the state of your app, which is really easy to think about. Now to the nuts and bolts of how to write this code. Getting started with Redux is easy. For Redux Kotlin, everything is on Maven Central, so you can add the dependencies. They're built with Gradle metadata enabled. You may need to enable this also, but this means it will add the dependency to the correct platforms. Then we need to write the Redux components. global app state is needed. It can be a data class. Actions must be created. Typically, these are data classes as well. I like to group them as inner classes for organization, but that's not necessary. Any object can be dispatched as an action, so there's no need for implementing an interface here. A reducer is needed to update the state. This is usually a when statement that switches on the type of action. It creates a new state. Using the data class copy method is useful here. As you can imagine, this function could get really large quickly, and there's a couple ways to address this. One, you could have actions do the reduction itself by implementing an interface, or break it up into multiple reducers. Middleware functions are created using this helper function. Middleware takes the store, a next dispatcher, and an action as parameters. The next function here dispatches to the next middleware in the middleware chain, or the reducer if there is not more middleware. In this sample, logging middleware, it logs the name of the action, then passes the action to the next dispatcher. And a store must be created using the create store function and giving it our reducer, an initial state, and our middleware. So now the store is set up and actions can be dispatched to the store. Note there's multiple ways of creating these components. For example, reducers can be functions instead of vowels, or you could use classes. It just needs to conform to the type alias as defined in Redux Kotlin. Now to our thin view layer on Android. The activity subscribes to the store and onCreate. The subscribe function takes a lambda as an argument. Here, the lambda is calling the render method with the current state object as a parameter. This lambda will be called every time there's a state change. The subscribe function returns us a store subscription function. This is a function that's used to unsubscribe to the store when it no longer wants to receive state change updates. And this is typically done in your own destroy. Calling the unsubscribe function removes the reference from the activity from the store and avoids a memory leak. And dispatching actions is done with the dispatch function on the store object. There's here a user logged in action is dispatched with a new user object. This is a contrived example, but you can imagine using a click listener. So that code creates this architecture. It gives us unidirectional data flow, which is good, but this is just a starting point for Redux on mobile. There's a few problems you'll quickly run into. One, the state may not contain data in the format that your view needs, and you don't want to be transforming your data in your view. And two, the render method is called on every change. This may result in setting values on views that have not changed and unwanted UI effects. So we can do better. What we really want is to only update the view when the substate the view cares about changes, and then to create a view state containing the formatted data that is ready to be displayed. I like to call this the presenter function. It has one job: select state and pass view state to the view when it changes. Then we need a view interface so we can call methods on the view. This may just be one render method, but often we need more than one. Using Kotlin and some functional program techniques, we can get some very concise code to write these parts. I've written a middleware called presenter middleware to make this easy. Let's look at an example from one of the sample apps from reduxkotlin.org. Defining the interface for our view is simple. It's just a matter of defining methods for different states of the view. This is probably really familiar to a lot of people from other architectures. The presenter function is provided here. The presenter type is from the presenter middleware package. A default implementation is provided for the interface here named start presenter. Start presenter is defined as a val. It uses the presenter function provided by presenter middleware. This takes a view interface as a type parameter. The presenter function takes a presenter builder as a parameter, and a presenter builder is a lambda with receiver that returns a lambda with receiver. I know this is a bit unusual, but what you have now is a block of code with access to instance of the view and the state. Everything in between the double curly braces has access to the view and the state. The injection of the view and the state are completed by the presenter middleware. It takes care of subscriptions and lifecycle management. I'm not going to dive into the details of this, but if you're interested, the source code is at reduxkotlin.org. So inside this block, we can write some really concise code for selecting state and doing updates to the view. The presenter middleware is built with memoized state selectors, so only updates the view when a new value is given by the select statement. Let's look more closely. The select function is defined here. Its function takes a lambda that returns a substate from the app state. The then function is an infix function that defines an action to be taken when the new value of the substate is received. And the body of the function is ran when the substate changes. Here we call show loading if the state is marked, if the state has marked is loading is true, and otherwise called hide loading. Show loading and hide loading are methods from the start view interface. Because this is a lambda with receiver, the view is the implicit this within the scope of the presenter function. Now, the style of this code is not typically what we usually write. However, within this narrow scope, where we are only concerned with linking substate to calling view method, I think this is okay. It becomes clear what's happening in the presenter function. What is really interesting is there's no state in these functions other than the memoized substates, which is abstracted by the presenter middleware. And there is no lifecycle shenanigans. That's all handled by the presenter middleware. Using the presenter middleware is easy. It's really a store enhancer. So you include the dependency. It's a one-liner. You install the store enhancer in your create store method. And you can see it here, use the compose method to add 2 different store enhancers to the store. Next, a presenter lifecycle observer must be used on any view with a presenter function. In your activity or view, that would be done with this code. On iOS, there's a similar code to connect view controllers. And that's it. It's now possible to write presenter functions and have view interfaces, and the presenter middleware takes care of managing subscriptions and memoization. This is a really new pattern, and anyone is welcome to try it. There may be some situations where it's not a fit, something I'm exploring, and I want to continue working on. But that's all I'm showing of that today. If it's on reduxkotlin.org if you're interested. So the presenter middleware can help us get this architecture with very concise code. It can be added to the project really simply. And I think this is the power of having an ecosystem and a standard Redux. Store enhancers and middleware such as this can be published to Maven or JSON and added to, really quickly. I have 2 open source sample apps that are using this architecture on GitHub. They're both multi-platform and support Android and iOS. One is a name game app where you guess the breed of cats and dogs. It has a voice mode where guesses can be spoken. The other is a reading list app where you search for books and create lists. These are fairly simple apps, but they're more complex than a to-do app. They have networking, scrolling lists, and asynchronous actions. So I think this is a good place to get started. And they both use the presenter middleware. Okay, so Redux can work in apps pretty well today. And we can share a lot of Kotlin code between Android and iOS, and even other platforms if we like. But front-end mobile development is changing soon. Both Google and Apple announced SwiftUI and Jetpack Compose. Both of these use a declarative style, and they're radically different. What's going to happen in a few years when we may not live in a world with activities and fragments or view controllers on iOS? Using MVP or MVX architecture, there will likely be a lot of refactoring needed. The interesting thing about Jetpack Compose and SwiftUI is how similar they are to React. They both have declarative UI, and they break components into essentially functions that render UI from state. React and Redux have been popular combinations since 2016, and Redux has in part been used to solve the difficulty of sharing state between React components. Movie SwiftUI is an open source app by Thomas Ricciard. It's one of the most complete examples of an app written entirely in SwiftUI. It allows you to browse movies and discover actors in upcoming movies. You can curate a wish list and a scene list. It's really nice. He wrote this entirely in SwiftUI and ReSwift, which is a Swift Redux library. I was able to fork this and pull the Redux and other code into a shared Kotlin module, and it worked really well. The video you're watching is the Kotlin version. Note there is some stutter and jank in this video, but that's not coming from the Kotlin side. It exists in the pure Swift as well. It's a limitation of the pre-release SwiftUI. The shared Kotlin code contains networking, models, the app state, reducers, user preferences, save and restore state logic, and date formatting. The Swift code is now only the UI layer, and the shared logic can be reused by other platforms, such as Jetpack Compose. Now, how to use Redux and SwiftUI. I'm going to go through this really quickly, being this is probably a room full of Android engineers. Of course, the source code is available online. SwiftUI is still beta, so these APIs are subject to change. But this is one approach that works currently. The store can be passed as an environment object to the root view of the app. And every child of the root will now have access to the store through the use of the environment object property wrapper. The store is an observable object that will cause a redraw whenever there is a new state. And because of how SwiftUI does a diff on the views before rendering, and only updating views that haven't changed or have changed, this is completed efficiently. This can be further simplified by creating a protocol that the views need that can implement and requires a map and render function. The map function maps from the global state to a props type, which is data formatted for the needs of the view. This is basically what I was referring to as view state as before. This pattern is very similar to React Redux. The result are views that only have to implement the prop struct and a map function. And this pattern seems pretty scalable. There's not a lot of boilerplate. The logic is specific to this view, is contained within the view struct. This is how Movie SwiftUI app is structured. In this code snippet, the state object is from shared Kotlin. Here, in this particular example, the prop struct and the map function are in Swift. However, this could also be put into the shared Kotlin. How about Jetpack Compose? How can we integrate Redux with Jetpack Compose? It's actually pretty easily. In this example, a list of movies is displayed. The list of movie only needs to be updated when the list changes. This shows how a substate can be selected and observed. The select function is an extension function on the store, and it creates what's known as an effect in Compose. It will automatically redraw the movies when the movies in the global state changes. It also will automatically manage subscriptions to the store. I'm not going to dive into the details of the extension function, but again, it's open source and online at reduxkotlin.org. Jetpack Compose is not quite ready for a complete sample, such as the movie SwiftUI, but we can test how global state will work with Compose functions. This demo is sharing network and Redux code with the movie SwiftUI, and it's basically a basic layout of the Now Showing tab. My plan is to build this out as Jetpack Compose matures. All the source code is in the movie SwiftUI-Kotlin repo. So what's next for Redux Kotlin? I think it's pretty clear that it's a useful pattern today, and it's likely going to be more useful in the future. I plan to starting a reduxkotlin.org website similar to redux.js.org, and could have how-tos, best practices, FAQs, etc., and continue to flesh out apps and adding Jetpack Compose as it matures. Explore Android, iOS, and React an app using shared Redux code, and integrate with dev tools, such as the Chrome Redux dev tools, and hopefully add contributors to the team. If there's any interest, you can contact me. I think this is a good opportunity to contribute to an open source project. To wrap up, reduxkotlin.org aims to be a standard Redux for Kotlin projects. So I think we should build an ecosystem. It's not necessarily going to be exactly what I have now, but I think this is a starting point. It's able to be used today, all the source codes at reduxkotlin.org. Welcome feedback and contributions. And thank you for WillowTree for Innovation Time to work on this. We are also hiring, so if you like building great apps with a great team, check out willowtreeapps.com. And if there's any questions, feel free to ask.